Okay, geology class, welcome again. This is Glaciers video lecture, I guess full video lecture number 3. I had half part of one with streams. I wanted to pick up with a couple of, one point that I was talking about last time. We were talking about glacial erosion. And one of the things that I had showed you previously, a long time ago, were these scratches in a rock that I said were glacially done, glacially created. And those rocks are those scratches are called striations. We talked about glaciers moving over the bedrock and incorporating into them the sediment from the bottom of the glacier. And this image here, I think, helps us visualize that. So this glacier moving, it's picking up sediment underneath it, carrying it along, and all the way to the glaciers on top of that sediment. It's pushing down on the bedrock that it's moving over, and it's abrading or scratching the rock that it is moving over and creating rock floor. Well, another thing that it is also creating are these striations. So as that rock floor is created, these striations are created. And we see them, here's some columnar joints that have been polished by that glacial action. And you can see those fine scratches that have been embedded into that columnar joining that we talked about with volcanism. Another place, I don't know if you've ever been to Central Park. I've not been there, but I've seen pictures of it. In Central Park, there are a number of exposed bedrock areas that have glacial striations in them. Here you can just make out this idea, this notion of scratches, but there's a big area here where the striations are longer and more embedded in the bedrock. Again, this is Central Park. Which is that part of New York is an extremely glaciated area. There are piles of glacially created sediment that much of New York is built on, as well as this glacially polished bedrock. We don't have to go that far away, though. This isn't the best picture. This is one of my former students, and she's actually on her way to her husband's graduation from med school in Duluth. And she's up by Cloquet. And in the median on I-35, there are a couple of places where there's that same polished exposed bedrock. It's a little bit harder to see the striations here. I got to get out and do this myself sometime. But yeah, we can see those same things in that area just north of the cities. Okay, so what I wanted to then do next then is to talk about some erosional and depositional features that glaciers create as they move. So erosional. As glaciers move, over the surface, they erode the landscape, which we've already made that case. And as they do that, they create very specific glacial features. Okay, I don't need that one. So one of the things that they create is a U-shaped valley. Okay, and if it's a stream, it'll be a V-shaped valley typically, but a glacier creates a U-shaped valley. And if you think about why, I think that can make some sense. If you can picture a glacier filling this valley, I don't think I have a picture of a glacier underneath another U-shaped valley. There we go. Interesting enough, this is near Horn Creek Ranch. Remember that term, Horn, because that's going to come back in south central Colorado. That's an obvious U-shaped valley. But I guess we'll go here. So if you can picture this valley being filled with a glacier, rim to rim, there's more ice sitting over the middle of this valley and less ice as you go out from it towards the margins of it. And so that's going to erode the landscape variably, with more erosion happening in the middle, but less, still some, but less on the sides of the glacier. And if this were a stream valley, it would just cut into the valley progressively and make more of a V-shaped valley. So U-shaped valleys are very characteristic of glacially eroded landscapes. If you remember previously, I had a Cirque glacier. Did I have a picture of that yet? I guess I'll pull that up here. I had we're talking about alpine glaciers, and I said a Cirque glacier was one example of an alpine glacier. Shucks, all thumbs here. And I used this picture to show you one, and the fantastically involved definition of a cirque glacier is a glacier which occupies a cirque. So this is a cirque glacier, and it is in a cirque. And if you can picture this thing sitting here just like a belt sander on a board, but you're not moving the belt sander. So snow is moving, is gathering here, moving through that glacial system and exiting it. And as it's doing so, it's grinding away at the mountainside that it's sitting on, and creating this specific feature called a cirque. And I'll show you a picture of one. Once the glacier is gone, well, there's still some glacier there, but it's eating into that mountain and gnawing out, if you will, this cirque. Of course, it's going to be deeper in the middle, just like a U-shaped valley, less deep on the sides because the ice is not as thick. And yeah, and you get a cirque. So here's a picture of several cirques. Okay, this would be a cirque and a cirque glacier in it yet. Here's another cirque. Here's another cirque. Maybe the best example is in the Faroe Islands, and I'll show you where these are. We're north of England, between England and Iceland. Okay, and so if you zoom in on the Faroe Islands, you can see maybe better than most places. The whole place is made up of cirques. Each of these little half round shaped notches would be a cirque. And all over the islands there are cirques. And people live there. And these, of course, weren't always flooded between them, but they are now. And yeah, the Faroe Islands. Okay, so that's a cirque. If you can picture that glacier, again, it's important to visualize that glacier like a belt sander. It's constantly moving, albeit very slowly, imperceptibly almost to our thinking. But as it sits on land, the glacier is abrading, it is eating away at the landscape that it's sitting on and moving over. And a cirque is a feature that can be created by that. If we can zoom, we'll just zoom in on this just a little bit more, because this isn't a bad, yeah, this is a real good spot here. If you look at this spot here, there may have been a valley glacier here, but now we have a cirque glacier here and a cirque glacier here that used to be here. And they sort of, well, even, you know, you could just imagine a cirque glacier here, doesn't matter. But you have this erosion going on of this rock island, this rock spit of land, if you will. And you could look at this glacier eating away at this side, this glacier eating away at this side, and this glacier eating away at this side, and it creates a very pointed peak called a horn. And if you remember earlier, I talked about a U-shaped valley, and I said it was near Horn Creek, Colorado. Well, there is a horn there, and there's a very famous horn, and I think you know it. This is not Horn Creek. This is a European horn, but again, there was a glacier sitting here, one here, and on the other side, maybe two on the other side, and it's created this feature here. And I think you know this mountain. It's in Switzerland. It's called the Matterhorn, and that word horn is derived from its glacial origins. And if you think about what the Matterhorn is famous for, it's famous for its difficulty in climbing. If you're a mountain climber, this is one of the mountains that you want to put on your list. And the reason for that is if you can picture this glacier working away at this side, it's going to polish and smoothen that side, any side it's working on, and make it very difficult to find handholds and to climb. And that's why the Matterhorn is, in part, why the Matterhorn is a famous mountain for climbing. Well, if we go back to the Faroe Islands, and we zoom out a bit, you can kind of see a spine or a ridge down the middle of these long spits of land. And that spine or that ridge down the middle has a name as well. It's called an arête. And if we look at them closely, here's a gentleman walking on one. I hope he's got good footing, because if he slips either way, he's toast. So you picture a glacier eating away at this side, a glacier eating away and polishing this side, and it creates an arête. This one's rather dramatic. There's some that are a little less dramatic, like this one here. It is a popular place for a trail because you have such a good view on the top. But in the previous example, Yeah, it's a little dicey of a walk, you know. But anyway, that's an arête. Again, created. It's mainly two sides that we're interested in, created by a long, narrow ridge created by two glaciers working away. Okay, another feature is something called a hanging valley. And I think, arguably, it's one of the most beautiful features that glaciated landscapes contain. I'm going to shrink this picture just a little bit so you can see it all in here. This is from Alaska, and maybe just a little bit more. And here you have, this is an ocean inlet, and there's this valley that's left suspended above that ocean, and a stream flowing through it, and just a waterfall as that stream cascades down the lip of that suspended valley, hanging valley, and into the ocean. And if you could picture a glacier forming this U-shaped valley, maybe even it still exists up valley a ways, and melting slowly and creating this stream, maybe another lake here, maybe another waterfall here. Beautiful feature. It's suspended, it's a hanging valley because the valley here may have been created by a valley glacier, a bigger glacier that eroded more rapidly into the ground that it was sitting on and left this one, which was created by a smaller glacier and didn't erode as fast, suspended above. To give you an image of what that might look like, here's a glaciated landscape. And so there's this large glacier here that's moving over the surface bedrock. And then there's these two other smaller glaciers here. This one actually is an ice cascade, an ice fall here. And you can see that when the glaciers would leave this particular area, this valley here created by this big glacier here would be much deeper and would leave the valleys created by these glaciers suspended or hanging above the valley floor. So a hanging valley. Well, let's talk about a few depositional features then when it comes to effects glaciers have on landscapes. So the first one we're going to talk about is actually, I'm going to put an image up here, and we're going to cover a number of them with this one image. Oops, not the one I want. Yep, that's the one I want. Okay, moraines. Moraines are piles of glacially created or glacially derived sediment. I'm going to shrink this picture down just a little bit too. And if you remember from that picture of the Valley Glacier, there are those lines on it. And those lines can be hard to explain, especially if you go look at them. Those lines are lines of ice, of dirt and rock that's sitting on and maybe embedded a little bit into that glacier, but mostly it's just sitting on the top of it. So how do you get rocks and dirt, sand, sediment, basically, out here in the middle of glaciers? Is there somebody upstream sort of slowly dumping it on through time and carrying it downstream? No, these are moraines, piles of glacially derived sediment. So if we look back here, here's a tributary glacier, and here's a valley glacier, okay? And right here, this is where the one glacier would be grinding against the side of this rock right here, and this bigger valley glacier would be grinding against the side of it here. And so there's piles of debris that would be created, maybe drop down onto the glacier right here along these edges. But now notice now when the two glaciers merge, now that point is out in the middle of this larger valley glacier, and here's this line of sediment that was created at this point right here, but it's carried downstream. And it definitely makes the case that glaciers move. It's a flow line, if you will. So this moraine right here is created back upstream where this glacier and another merged, and this one as well. And so right here down in the foreground, let me just scroll this down just a little bit. You can see that actually happening. Here, this valley glacier and this valley glacier here, they are merging and creating a moraine. This is called a lateral moraine if it's towards the edge. These are all medial moraines if they're towards the middle. There are only two lateral moraines on any glacier, but there can be multiple medial moraines. And this lateral moraine and this lateral moraine become a medial moraine when those glaciers merge. Okay, so yeah, it just makes the case that these glaciers are moving. And you can actually count how many tributary glaciers there are upstream by counting the number of medial moraines that a glacier has. So if we go back to that picture then, oh, not screencast-o-matic, right here, we have medial moraines. It's like your ligaments in your knee. There's a lateral collateral and a medial collateral. Lateral means towards the outside, medial means towards the middle. And well, then there's also a terminal moraine. No, that's not created where the glacier dies. That's created where the glacier stops moving, when it reaches its greatest extent. It's also called an end moraine. And so if we look at, well, there's more lateral and medial moraines. I want to show you this picture right here, because in this picture, we can definitely see a number of moraines. So here we have the glacier, and maybe you can make out this pile of sediment right here that I'm tracing, and then another pile of sediment right here that I'm tracing the cursor through. Okay, maybe even another one in the foreground here. There are multiple terminal moraines. Now, there can't be multiple terminal moraines though. These are the one that's the farthest from the glacier would be the terminal moraine. These other moraines would be called recessional moraines because they occur where the glacier stops moving for a while. Last time I showed you where the Jacobshaven Glacier that was featured on Chasing Ice had actually advanced again from where it had retreated to back in 2012, and on 2020 it's again farther. It's made advances. In so doing, it would have wiped out any previous recessional moraines. But you can think about the glaciers sort of ebbing and flowing, not just only coming one direction and then moving back. But that glacier might have moved forward for a while and or stopped for a while, but all the while it stopped advancing or retreating, but all the while it's sitting there, it's still acting like a belt sander. Ice is still water is still entering it as snow, being formed into glacial ice, moving through a glacial system and exiting that glacial system along with the sediment that's underneath it. So even though the glacier is receding, it's still eroding the landscape that it's sitting on. It's like that belt sander getting bigger and then getting smaller. All the while it's still moving and creating sediment. So there are terminal moraines wherever the glacier has reached its maximum extent. There are recessional moraines where the glacier has stopped receding for a while and continued to produce sediment. And then all the while, there is all this material here that was formerly under the glacier, whether it's in pile or not. It's called ground moraine. So that's 1, 2, 3, 4, 5 types of moraines. 5 distinct places we find glacial sediment. Now, if you can picture this glacier creating this sediment, a lot of it out front here, and meltwater coming off the glacier, it's probably not too hard to visualize that there's way more sediment here than can be transported by whatever meltwater comes off the glacier. And so this stream is flowing along and it's carrying lots of sediment. Anytime the flow slows down at all, it dumps a pile of sediment. That might be in the middle of the channel, it might be out to the side. I'm going to switch to another screen here. Gotta get comfortable. Actually, I might go back to that former one for just a little bit. So it's going to create a very subdivided stream channel, and we call that a braided stream. Can you picture all these multiple channels created because it's carrying so much sediment and it can't move at all, and so there are multiple stream channels, and it kind of looks like something is kind of just all woven around, braided, if you will. And even back here, where the stream is mostly one channel, probably a little steeper gradient here, but then when it gets through this terminal moraine carrying all this sediment, the channel gets greatly subdivided. And so then if we go back to that picture here, this is a braided stream, a braided stream minus the glacier in this case. It's still flowing over flowing over ground moraine. There's still way more sediment there than the glacier can move, but the stream can move, but you can really see the braided feet, the braided characteristic of that stream. And maybe the best picture of all is this one right here, because we still have the glacier. Look at the multiple channels that there are as that stream flows, the meltwater comes off the glacier and tries to move all the sediment that's there. And so this would be an outwash plain from that braided stream. Let's see. I think in the notes it has Paternoster Lakes and Tarns. I don't think I'm going to worry too much about those right now. I think we're going to stop at this point, and